Hello, everyone, and welcome to another exciting webinar with phoenixNAP and Arista. Today, we've got a really exciting agenda. We're going to be talking about all things network automation and how you can do them using infrastructure as code, which I think everyone's interested in some capacity at this point. More automation, more programmability gets wins for all sides of the organization. So my name is William Bell, Executive Vice President of Products with phoenixNAP, and today I'm joined by Fred Su and Carl Buchmann, systems engineers and distinguished solutions engineers for Arista. They're going to be talking about the market space and all kinds of cool things and the way Arista views network automation, as well as an exciting demo. So I think it's going to be a really exciting event, and everybody should hold on to the end. The reason that you should definitely hold on to the end is because we're going to be giving away a $100 Amazon gift card. So stick around and find out if you're the winner. If for some reason you got to go, we're not going to hold you hostage. We will announce that at the end. But I'm going to get started with a couple of poll questions. I want to try to gauge the audience's experience with network automation, infrastructure as code. This will allow us to really tailor our presentation, make sure that we're speaking to the right people. So if you do me a favor, I'm going to launch these poll questions, and they're going to come up on your screen. If you could please answer them for me, that will be huge. All right, here comes the first one. All right, so what's the biggest challenge in network management for you today? Is it configuration management, security and audit control and compliance, scaling, auto scaling? What's it look like? Interesting. We're getting a lot of votes. So this is great. I love the engagement. I love that everyone's ready to press a mouse button today. And I'm going to cut it off at 50%. So let's get a couple more people in there to press the button. All right. So basically, we were at about 27% configuration management, 46% ensuring security, a few people on scaling, a few people on cross-cloud management, and actually kind of surprisingly, only a few on vendor lock-in, though I think some of the things we're going to talk about today are going to make apparent why that might not be the case, since I assume most of you that are doing automation are probably using open source automation tools that are leveraging APIs versus doing it with a specific vendor's API natively. So let's continue from there. I'm going to shut down this poll and launch the next one. All right. And so for you and your organization, how long does it take for you to accomplish these tasks? If you're not, I assume that most of you are not performing wholly automated network automation today or network configuration. So, what does that look like for you? And I suspect that, it varies heavily by size of organization, right? What we see, our customer base, the larger the organization, the longer it takes to make changes. And a lot of that's more bureaucracy than the doing of the change. So it came in kind of 35% in a day, 48% in a few days, which, could be a long time, if something's important. And then, about 15% or so in the weeks or more category. So I think that's pretty representative. It's kind of what I would expect as we roll through that. So I'm going to shut that down, and we're going to get into the meat of the presentation. All right, so when we talk about the subject of today and kind of what we're doing from a network automation perspective, I think it would be remiss if we didn't talk about kind of some of the differences we see in the architectures of infrastructure and how that matters for network automation, right? As you probably are aware, the more traditional monolithic your network architecture, your server storage architecture, the harder it is to automate. It doesn't mean impossible, and certainly doesn't mean impossible, because we're going to show you at least how, from a phoenixNAP perspective, what we've done to make sure that we can automate the hardest things there is to automate, which is that metal, that switch, that router, that storage array, right? And then you've got kind of infrastructure automation for microservices applications, right? And in that ecosystem, everything is containerized or virtualized or both, right? And everything can be done very rapidly if you have the right approach and foundation to performing these kind of automated tasks, right? compliance control, and Fred and Carl are going to talk through that, right? In real world scenarios, what that looks like to get end to end through that entire, like, we want to make a change to all corporate governance, to dev test, to production, right? And it can be done, and it is being done by organizations around the globe today. So, don't fret. All right. So the basics, right? I'm going to talk about the basics. Fred and Carl are going to go into the nitty gritty, and we're going to give everybody in the audience today a little bit of what hopefully they're looking for, right? And so when we look at infrastructure as code, what we're talking about essentially is ensuring that you can that more than just just established network engineers, server engineers, storage engineers can leverage programming technologies, code essentially, to automate creation, updates, and destruction of these types of resources. So you want to be able to scale and orchestrate, do it via programming language of your choice. It also, kind of the heart of this infrastructure as code is getting that ability to constantly test and implement, right, in a very compliant and governed way. And corporate governance compliance is really a lot of times around configuration management and reasons and why you're doing things. And the end-to-end pipelines that Fred's going to show, they really touch on all components of that, right? In terms of ensuring that you're establishing why you want to make the change, how you plan to do that, making sure your applications are compatible with the change that you're going to implement. All of these things ultimately lead to developers and application engineers having an easier time getting faster delivery of their applications. And hopefully for the business, that means money, right? Getting these things done faster means money, because you get more competitive advantage, you get better technology and updates for your customers. We could sit here for an hour and come up with reasons as to why this is important, but this is why we're doing that. That's why you're here. That's why we're here talking to you about it, right? Because this is what people are looking for when they look at network automation, infrastructure as code specifically. So when we see, these trends, I think that what we're, looking at is a mix of traditional and monolithic infrastructure leading to a predominance of organizations being, a predominance of organizations having some level of automation, right? I would hesitate to say that this is a complete picture, only because, I would imagine that most of the automation that's happening, right, is happening in modern applications, and it's sometimes it's for capability reasons or technology reasons, but I think all three of us on the call today would urge you to look at both traditional and modern applications or microservices, whatever category you want to put the modern applications, greenfield applications that are being developed, and say that you should at least attempt to automate most of that, traditional and modern, because you're going to get a reduction in repetitive work. You're going to get better scaling efficiencies. You're going to get faster time to implementation, and you're going to improve your compliance and security, because every change is going to be tracked and implemented for a very specific reason, right? And so, I urge everyone that the deck will be available in the handouts area. Go through these, read these. I'm not going to hold Fred up in getting to some of the good conversations that we plan to have. So I'm going to jump forward a couple here. And so, why do we need this? Like, why are we here? Ultimately, everyone's here for simplified management, because the networks have become very complex, right? I'll show you guys a slide later in the presentation, but just, PNAP, as a service provider, we obviously have a large complex network, right? But I think that at this point, there's well over 1,500 to 2,000 devices, maybe more, right? Across 18 global locations. Like, if we didn't have automation at the core of what we're doing, we would be in trouble, right? Because there would just be no way to implement these changes in an efficient manner, right? And so I think that even small organizations that maybe only have 1 or 2 network engineers, or maybe no network engineers on staff, right? They find themselves with large and complex networks, whether they're virtual networks or physical networks, right? And I think that that's important. Some of you on the call today might be completely cloud-centric, cloud-forward. You don't care about Arista switches. You don't care about PNAP service providers. You're with AWS, right? But even for you, implementing network changes via infrastructure as code is important because it is going to make your operational efficiency better, your security better, and your ability to be continuously compliant better. And so you get all of that. You get the ability to interact with other components. And I'm gonna pass the ball over to Fred and let him kind of take it, and he's gonna pass it back to me at the end here. So let me know when you're ready, Fred.
I am ready to go.
Okay, there you go. Go ahead and present your screen. Take it from there.
Thanks. All right, let's see. You guys seeing my screen okay?
It's good.
All right, great. See, we can roll with the punches. All right. Well, hi everybody, and thanks, William, for the setup here, because I think what we're going to talk about aligns really well with what William was talking about in the beginning. And I want to take one step back here, and at Arista, when we're looking at infrastructure as code, we're seeing this as part of a bigger picture. And I think that poll actually helped indicate some of the other problems that are related to things that you would solve with infrastructure as code. And so we're going to focus on this far left one here, DevOps, CI/CD, and treating your code or your infrastructure as code. But there's also a lot of other things configure in this as well. So, we got cloud first kind of mentalities where folks are wanting to do things on-prem, much like they would in the cloud, or they would with their providers. Zero trust, so obviously security is a big piece. I think that was the highest ranked item in that first poll. So how does zero trust fit into all of these things? So I think all of these things are very much interrelated. And then to get a little buzzwordy, AI and NetOps, just at least have to cater to the marketing folks a little bit. But as we do these things, it actually does start to enable AI and NetOps and things down the line. And so as we look at what we kind of experience with the different customers we interact with, we see kind of folks on this continuum, and there's no right or wrong, and there's no you don't have to necessarily go to the far right. We have very sophisticated companies like phoenixNAP who can do things on the far right of this, and we have some companies who are still working their way through the far left of this. But the idea is that as you start to increase your network operations maturity, and as you start to adopt a lot of these tools like infrastructure as code, the kind of the timeline you see on the bottom there is how you can move from making changes, once a quarter to once a month to once a week to once a day, even to within hours. And so depending on what your business needs are, you might want to be at different stages along this spectrum. Kind of the big first chunk is to move from not repeatable patterns to repeatable patterns, right? So even just structuring your network architecture with a leaf spine network or with cookie cutter designs, that just facilitates automation later on. Then we see customers moving to sort of read-only automation. So being able to monitor everything that's happening there, being able to pull in configs and back them up, but not actually making any significant changes on the network until you're familiar and comfortable with the tool sets. Then we move into start to automate things with your system. So starting to use Ansible, starting to use a lot of the tools we'll discuss here in the presentation. And here's where we like to start to inject testing, right? So in order to make you feel confident and comfortable with doing automated changes on your network, you also want to throw some kind of testing into this as well, so you make sure you didn't mess anything up. Then we start looking at sources of truth. I know William also indicated this in his slide. So having some kind of database, some kind of place where all the data is coming from to kind of initiate these changes and to reflect back on these changes is super helpful and really starts to take you up to where you can actually do these things in a much more automated and predictable fashion. And then again, you can move on to the far right. Once you've got all this stuff automated, now you can start looking at how can I leverage more advanced tools on the data that I've collected. So now one of the big problems we've seen when we've talked to a number of our customers is just getting started. And so when you kind of enter this space, you're presented with a myriad of options out here, right? It's like walking down the cereal aisle and being presented with 1,000 different types of cereal, and you can't choose which one because there's just too many choices. And so to kind of help people along this path, what we've done is we've kind of come up with an opinionated set of tools that we're testing with, that we've seen a lot of customers have success with, and we recommend. But by no means is this carved in stone, right? So if for whatever reason you need to switch one tool out with another, this is a very composable infrastructure here. So you can absolutely swap out, let's say, GitLab in this picture with GitHub, or Ansible with Salt. Totally customizable to your environment, but just for those customers who are really struggling to get started, we wanted to give people a basis and a starting point. And so this is kind of the reference architecture we've been proposing. You can see we start off with just being able to kind of compose your changes and edit your files. VS Code is a fantastic environment for this. Actually, William and I were just mentioning before this call how, you know, VS Code is actually just an incredible environment, even with all the super fancy commercial solutions out there for Xcode and whatever else. VS Code's really taken off as an excellent place to be able to do this stuff, and it's free. And just another kind of common theme you'll see here, we're trying to leverage open source and free tools as much as possible. Most of these, if not all of these, have a commercial component too, but at least for people getting started, it's nice to be able to try this stuff out without any kind of serious commitment. GitLab as a code repository. So as you move down this journey, you're going to want to use Git. You're going to want to store your code or your configs into some kind of version control. The reason we like GitLab here is, one, it has both a cloud and an on-prem component. So for folks who want to run on-prem, they have the ability. And the second reason is it has a built-in CI pipeline. So you don't have to run GitLab and then, or some repository and then also fire up Jenkins or fire up something else. You can get everything you need in one deployment. But again, very customizable. We know we have a lot of folks out there using the Atlassian tool set, who are using GitHub, who are using all these other tools. Use what you need. Now here in the pre-deployment testing column, this is where things, I think a lot of folks aren't familiar with a lot of the tools, or the tools that we're outlining here. And the big one I'm going to highlight is Batfish. And for those who aren't familiar with Batfish, it's an open source project that allows you to do pre-validation testing of your network changes. And it does that by modeling out your network using a bunch of fancy algorithms. So it doesn't spin up VMs, it doesn't spin up containers or anything. It actually takes all of your network configs and then actually kind of interprets all the configuration CLI and then models out what your network looks like. And then you can run queries against it to say, hey, did my ACL do what it's supposed to do? Did I get the right routes on this router that I expect? So it kind of models out your control plane unless you run queries. Then we move into release and deployment. Here, Ansible is kind of king in the network world, I think. Again, we see some Salt, we see some of the other tools as well, but Ansible really is the predominant tool we've seen there. And we've got a lot of awesome tools Carl and team have built up, and we'll go into that a little bit later with AVD and some of the really awesome work that our Ansible team has done here at Arista. Here's also where we inject CloudVision for the enterprise customers who are interested in CloudVision. It's our configuration management and orchestration tool. It works really well with Ansible and gives you some levels of controls that you may want to have with config rollbacks and monitoring your configurations, also compliance checking, and also streaming telemetry. And that's what leads us into the last column here is kind of how do we look at things after we've made our changes. Two tools that we're highlighting here are Arista tools. One is our DMF, our dance monitoring fabric, which allows us to do packet level monitoring. And then again, CloudVision, every Arista device does streaming telemetry, so we can get real-time statistics. We store that in CloudVision, we present it as graphs and stuff, and we can also allow you to look at it historically. There on the bottom is kind of this underpinning source of truth that we want to have, as well as documentation. So Nautilbot being one of the kind of foremost tools out there. Also, people use Netbox here sort of interchangeably, allows me to kind of put all that stuff into a centralized database and extract it as I need to feed the rest of these tool chains. So what we're going to do in a second here is go take you through a demo, and the demo is going to kind of work through this workflow. So we'll make some network changes. We'll look at them in the source of truth. We'll then use our AVD framework, which is Arista Validated Design. So this is an Ansible collection that we've published, actually Carl and team have published, that allows us to kind of abstract away a lot of the network intricacies and deal with network configs at kind of a higher level and roll out very complicated changes very easily. Then we're going to go into the static testing, or pre-commit testing. So before we push these changes out to the network, we're going to use Batfish to test out what changes we're doing and making sure that we're actually doing what we expect. And here's really, again, kind of a big point here. We like config rollback. We support config rollback, and it's an awesome feature. But if you do a config rollback, you've probably messed something up in that process, right? I pushed out the config, it goofed up, and then I had to roll it back. Instead, what we want to do is try to avoid that scenario to begin with. We still need it there in case we do still mess up, but with something like a pre-validation testing, I can actually test out these changes, make sure I feel comfortable with the change before I push it out there. Then we're going to go through a kind of a PR merge request process, as you typically do with code, and then we will deploy it out through Ansible and CloudVision. All right, so with that, let me pop over to the demo. All right, so we're starting off here in Nautobot. So again, this is our source of truth, and this is just a way for us to store a lot of data with regards to how my networks are set up. Nautobot, just a quick little intro, is a neat tool that lets you store information about where your racks are, how your things are wired up. A very powerful tool for just kind of network infrastructure management. What it also can act as is an IPAM. So I can store my IP addresses, it can hand out IP addresses, track my IP addresses. And for this demo, what we're going to do is show that we've put in a set of rules that's going to say if any of my IP addresses I've tagged as critical, I want to make sure that my network devices always have connectivity to these critically tagged IP addresses. So this could be, my DNS servers, my NTP servers, whatever I deem as essential. And so what that does is it's going to generate this list of permitted IP addresses. So this has been auto-generated from that Nautobot list. And so these are the exact same ones that I've tagged as critical. And so now I have a list of IP addresses that I want to test against whenever I make a network change. I want to run tests and make sure that these addresses are still reachable. So what we're going to do now is actually go through and make our network change. So I'm switching over to a new branch of code. Here I'm using VS Code, as we mentioned earlier, to make this change. And I'm adding in this new ACL. So you can see that sequence number 5 there is my new ACL that I'm throwing into the config. And this is being done through our Ansible AVD structure, right? So I'm using AVD to push out these new and generate these new configs based on what I've entered in the YAML file here. And so once I make this change, I'm going to save this file, and I'm going to push this up to, or commit the code, and then push this up to my repository. Once we commit the code and we push it up, this is going to trigger our CI pipeline. So here's where the CI piece starts kicking in, right? So the other thing we have in here is that when we do these pushes, we're automatically firing off Slack notifications. So this lets the rest of the team know that, hey, somebody's made a change. Make sure, can you go back and take a look at it if they want to, and we'll fire up the pipeline here. You can see we start rolling through the process. So the first thing that we're going to do in the pipeline is generate the actual configs, right? So this is using Ansible and using the AVD structure to generate the configs. Once those configs are generated, we're going to pass it through Batfish, and we're going to run it against its tests. And again, Slack is going to let us know along the way as these different stages occur. So in a second, I think we'll get a Slack push, and we should see that we're ready to go review what's happened. So you can see now we failed our stage because that new ACL that I put in actually blocked access to one of my critical servers, right? So it blocked access there. When we pop over to the pipeline, you can see that we failed that validation stage, and you can see that our traffic is unable to reach that particular IP address, which we deemed as critical. So again, this was automatically done based on my network change and based on the policies that I've enacted through our source of truth. So let's go back here and fix my mess up. So we're going to comment out that ACL change, right? So now we're no longer blocking access to the subnet that we should be able to access. We'll push this up, and it's just going to kind of roll through the same process again. So it's going to go, it's going to push the new thing up to the repository, it's going to trigger the CI pipeline, and we should get through, and we're going to pass all of our validation checks this time. And again, this could be other things on the network too. If I want to check to make sure routes are available, my routing table has a certain number of entries, route maps are doing the right thing. This is really pretty open-ended, but we're just showing you ACLs here as kind of a simple use case. Now, once this is done generating, we can go through and actually kind of finish our process here, right? So here you can see that this time we got a green line and everything's looking good. If I refresh the page, you can see that we passed our validation phase and we're ready to move on to the next step, which is to merge this code or my branch into the main configuration branch. So I did this all kind of in my own little branch. I made sure everything worked, and now I'm ready to merge this into the bigger pipeline. And so to do that, we want to make sure we have approvals. So we could make this, requires 2 people to approve before we actually are allowed to merge. You can see the results of the tests. I can look at the diffs. You can see those 2 little green check marks, meaning that we passed all of our stages, and now we'll issue the merge request. So now we've taken what I've done in my local branch, and I'm actually going to push this into the main branch in the main configuration to be ready for deployment out to the network. Now, during this process, we want to make sure that nothing really weird happened between when I submitted and tested my stuff and we're ready to do the full merge. So we're going to run through the pipeline just one more time to make double sure that we haven't messed up anything. Other merges came in and things goofed it up, but it looks like we're good to go there. Now, another piece I want to show you is as part of this process, again, we're using that AVD framework in Ansible. And one of the neat things that AVD does is it auto-generates documentation about the network based on whatever configs it's generated. So I've actually set this up to automatically update another repository with all of our rendered documentation for a config. So this is a nice output that just got auto-generated by the tool. And here you can see the ACL entries that we've created, nicely put into a table here, as well as the actual config that's going to be pushed onto the switches. And this holds true for all the rest of the configuration there, as you can see as well. And then along with that rendered kind of documentation config, it's also storing and creating the actual config that's going to be generated for the devices. So AVD has some other really nice features kind of outside of just generating the configs. It's doing all this documentation and stuff, so your docs stay up to date, which I think most of us are guilty of not keeping up to date when it comes to network infrastructure. And so now we're ready to do this final deployment stage. We've made this a manual phase because we feel like a lot of folks just want to still have a human hit the play button there and actually push the change out to the network. You could automate that and just have it roll through if everything passed, but I think most of us just feel better if we have a human hit the play button. And so here I am on CloudVision. And so what we're going to do as part of this change is it's just going to automatically push all these configs into CloudVision and then allow us to use CloudVision to actually deploy it out to the network. So if you look here on my configlet screen, you can see that we don't have any configs here with the prefix of demo, because that's how we're going to kind of signify the ones that we're pushing. And so you'll see Ansible's rolling through here, taking all the stuff that I generated in the previous steps and now pushing them into CloudVision. And so when I refresh on CloudVision, you'll see that as that process finished, I get all of these demo configs. Here's the one that we're kind of interested in, this Leaf 1A that we've been playing around with. And you can see that the configuration is now ready in CloudVision and ready to go and ready for us to deploy. So again, this is just a kind of a quick example of how we can automate this process end to end, how we can inject testing, CI pipelines, and true automation into the whole workflow. So with that, let's get back to our slides. One sec here. Oh, I'm getting goofed up between my virtual and my real. Okay, here we go. And so now let me hand it over to Carl to talk about AVD in a little bit more detail.
Perfect. Thanks, Fred. Hi, everyone. Let's talk a bit about AVD and what AVD ecosystem is all about. So, of course, as a vendor, we need to make sure we provide, the foundational modules to connect to some of our tooling, either directly to a switch with the Arista EOS collection or to CloudVision. right? But when we started this initiative about 2 years ago, we said, and when we worked with clients on their automation journey, they were building everything from scratch. And we thought, why not provide a more concrete way, show them how it could be done, and publish that as an open source initiative. So all of the content I'm going to talk to today is all published on either on the Arista Networks GitHub or on our NetDevOps community organization. So there's two places where we host content. And let's talk about the content that you see on the screen and how it's used within the ecosystem. Well, so first off, we publish a Docker container called Docker AVD base. This is very useful as we're trying to engage with the community and also internally with our development team of providing a consistent development and also environment that our customers can execute with. And we use this container as part of our CI pipeline to run our checks and validation on our various collection and content. So it's very useful. And we also have a specific version that also can integrate really easily. We talked about Visual Studio Code, so we also have a specific version for that to get you onboarded with a container on VS Code. And I strongly suggest that as an approach. It eliminates a lot of the heartaches around different dependencies that you require. And then if we go to the right, where we have the Ansible CVP collection. So this is fully maintained and managed by Arista, and these are the foundational modules. If you have Cloud Vision and you want to use Cloud Vision with Ansible, it's a collection to manage the facts, the devices, the containers, the configurates on the configuration and demo that Fred just showed was leveraging this under the hood. And then continuing in the circle, we have the NetDevOps community. This is where we provide community content for our transfer of information, our ATD education, and other content around automation with various tooling. And then if we go to the left-hand side of that quadrant, we have we invest a lot on quality on our collections. And one of the key tools within Ansible to support testing is called Molecule. And we develop a custom action for Molecule that allows us to test all, primarily focused on the Ansible AVD collection to validate all of the templates and content. And this is very useful as we bring in the community to help further develop or provide feedback, or if they send PRs, it ensures the quality of our code. And if you look on our collection online, you'll see the extensive CI pipelines that run continuously as we do code. And this is an important concept as it allows us to refactor adjusted code with not introducing bugs into the pipeline or into the code. So at the center of it all is the Ansible AVD collection. So as Fred mentioned, it's not just about building the configuration artifacts. It's also about building the documentation, so your documentation is always up to date. So as Fred entered a new access list, it automatically updated that documentation as well. Typically in an organization, that's the last thing that gets done, and the documentation, if I would poll the audience here, I would say, how many of you have 100% up-to-date documentation? I would suspect maybe 1 or 2%, 5% at max. Unless it's automated, it's definitely not up to date. And then the other key aspects is the validation. So what am I doing after I deploy my configuration? So Fred, in his demo, he focused on the pre-validation stage with Badfish tooling. In the collection, we also focus on what we call the network ready for use test cases. So being able to validate after the fact. And then obviously the important aspect is deployment. So we have roles that enable, essentially abstract the way you interact with either a workflow with Ansible or natively with the Arista EOS with EOS config to deploy to your switches. We can go to the next slide, Fred. So one of the important concepts when you begin automation, and especially a network, is to think about how you manage that configuration. So networks are distributed systems, so we have to think of them end to end. We cannot manage a switch box by box, or we should not treat them as a box by box element. There's a lot of interrelationship with them. So it's really important as you begin on that journey, you'll first, obviously, the first step is to do more of a device abstraction level, but then we want to help customers build the fabric abstractions. So within the Arista AVD collection, we offer both and leverage both as part of the, if a customer is using it end to end. So it first off starts by the device abstraction, which is the EOS CLI config gen role. And this is where we provide a YAML data model that is very similar to our EOS CLI. So it's really a one-to-one mapping, and it helps generate that full CLI content and also that per device documentation as well. It is also what we're able to use now that we have all of the data of the device in structured configuration format in a YAML format or JSON, is that we can query that data to build test cases. So when we're going to talk about the network ready for use test cases, an example of a large customer we did in Europe, after we deployed their large fabric, we generated over 25,000 test cases based on that data. And it's completely design agnostic when you do it in that fashion. And then if you look at the higher level, if we look at the fabric abstraction with EOS design, we then look at building, and right now the collection focuses on automating a data center with an EVP and fabric. Our plans are to support WAN and other use cases like a media fabric and other types of customers, but this is where we started first. As you know, Arista has primarily been a data center focused company, and we have a lot of customers operating large data centers. So at the fabric abstraction layer, again, we have different building blocks. If we start from the left, we have the connected endpoints. So these are devices that connect into the fabric. Network services would be our overlay services. Fabric topology would be how we interconnect our devices. Various fabric variables, common settings that determine how the fabric is configured. And we also provide the capabilities to customers to include their own custom templates for their own abstraction. So it's really important now we treat the design or the fabric as a role. So when we run Arista AVD against a network, we run it against all of the devices, because when we configure our spine, let's say with a new leaf, while we're touching multiple devices, we're typically touching, let's say it's a four-way spine, we're touching 4 spines plus that one leaf when it comes to configuration. Furthermore, we help customers, this is still a very network-centric way of looking at the configuration. Often customers want a more business service abstraction approach. So they'll create specific abstraction for, let's say, the network services and have something that accommodates their model. We can go to the next slide. So now let's piece everything together from end to end. So when we look at entering data, we look at entering data right now in a group or host var. So this is using more I'd say a GitOps approach. Nothing prevents us with Ansible, as we can connect. If your IPAM has an API, we can get data from that IPAM, or Nautobot. If we want to store data on Nautobot and use that as our source of truth, we can pull data from there. And then we feed it into that first role, EOS designs, which provide our abstraction layer. It generates that structured configuration, so that EOS CLI structured configuration output, which allows us to then create the CLI config with the EOS CLI config gen module, as well as creating documentation artifacts. So not only we create markdown artifacts, we also create CSV files of the topology data of the fabric, which is actually used then in the next stage with the Badfish role. So Badfish is able to create that topology using the layer 3 links, but it's not aware of layer 2. So for that, you either need to query devices with LLDP, Or in our case, with our pipeline, since we know the topology, we provide that in a CSV artifact, massage it to provide it to Badfish, so it's aware of the full end-to-end topology, including layer 2 links. And then we have our abstraction role, EOS config deploy CVP, which abstracts the way we communicate with CloudVision. We actually take also the Ansible inventory, convert it to our container structure in CloudVision, and do that mapping based on the grouping that you've defined. And then you can go through a change control or automatic push from CloudVisions to the devices. As a last stage is where we do the validation, and for this we just leverage the, we communicate directly to the devices and use standard, show commands that you would be accustomed to, like show BGP summary, get that data, evaluate against the structured configuration, and we do some asserts and some tests, and again we provide a report in CSV or Markdown format. And I believe that is it for my section. I think we have then the next slide, just some key links to some of our various collections. So the collections we've talked about today, we primarily focus on the Arista AVD and CVP collections, which are Arista maintained. And there's also the Arista EOS collection that is maintained by Red Hat, that provides more of the modules to connect directly to our device, like EOS config, EOS command, which we leverage in our collection, as well as various resource modules that are to automate the switches directly. So back to you, William.
Yeah.
Hopefully everyone can see my screen again. Guys, thank you so much for walking us through that. I love real world examples. I like to see exactly what it can be like for me or some other person or an abstraction of that person, right? And I think that what you guys communally walked through was the best reasons for adoption of these technologies and exactly how it can be done, along with a demo that showed it being done in practice, right? I assume, Fred, that's like your live Slack, right? Your corporate Slack. It was just sending things in there. Easy to do with GitLab and or other technologies. We're big fans of GitLab internally and GitHub, and I'm going to walk through kind of some of those things and why it is. So I'm going to flip over here real quick to the rest of our presentation. And so for those of you that are not familiar with phoenixNAP before you showed up at this webinar today, we have a global footprint, 16 data centers worldwide today. I said 18 earlier because it's more like 18, almost 19. We're just not on this map yet. We're working as fast as we can to spin them up, right? Hitting as many major continents as we can. We've got almost, I think it's even higher than that now. I think it's an old statistic. It's probably a little bit closer to 3 terabits of connectivity worldwide today, right? And so I mentioned earlier, thousands of switches. Our lives revolve around network automation. We have to be able to do this. And I think ultimately, as we get kind of towards some of our infrastructure solutions, we have to do it as end-to-end as possible with as little touch as possible, right? And so Fred kind of showed examples of running through policy-based decisions, doing end-to-end testing, and ultimately clicking that button and having that network change be implemented, right? And although we do that, we have other places where we can't do that. We have to have it so locked down, so tight that it is automated end-to-end. Right? And so we're focused every day on building and delivering OpEx infrastructure solutions, right? That's the core of what we do. We focus on the infrastructure. We're not an MSP. We're not focused on managing your environment every single day. We're here to help people that are in technology get and consume technology as a service, right? And allow them to stay in control of the things that they want to stay in control of. And so, as we build out all of our capabilities, our data centers, our infrastructure solutions, right? Security, redundancy, resiliency are at the heart, right? Obviously, our Phoenix data center's core, it is the data center of the Southwest at this point. Google Cloud just moved in. AWS has been there for a while. Got 2 more coming soon. So it's kind of the hub. So if you're in the Southwest, you're looking for co-location in the Southwest, there's not a better place to be for reasons of network connectivity and the fact that we don't charge cross connects to that connectivity. So between those 2 things, that's a big deal. But ultimately, our world, as it revolves around network automation, is resident in our infrastructure solutions. And our bare metal cloud platform is end-to-end automated infrastructure, server storage network delivered on demand via infrastructure as code tools. So in our case, you don't have to take some of these steps that Fred and Carl talked about, because we're taking those for you, right? You just say, hey man, I want a server and I want it now. And 90 seconds later, you have a metal server ready in your hands with your operating system, ready to go, ready to handle your applications and do whatever you need it to do. You want to do it in Go with our Go SDK? Fine. You want to use Terraform? Great. Ansible? Gotcha. Kubernetes controller? Got you. Like, we're making it easy to deploy infrastructure worldwide. That's the focus. That's where we're at, right? And that's going to be the core of our business long term, right? And so hopefully the things that you saw today popped a little question, made you think about what you're doing in your organization. Can you be doing it better? Can you add more value to the business, right? Because that's what we're all here for. People in technology, we don't exist without the business, right? We're here to make the business better, to make it more valuable. And ultimately, if you're in technology looking to make money, the closer you can get to making the business make money, the more money you're gonna make yourself, right? And things like network automation can save your company money, which puts budget back into other things. So I think that, you know, this has been fantastic. This is exactly what I wanted to hear from our presentation today. I'm gonna toss one more poll question up. Our marketing team makes me do this. So please, if you're interested in either talking to Arista or talking to PNAP, indicate, and we will have someone reach out to you. You can talk about whatever you want, even if it's just technology related, even if it's not sales related, just reach out and say, hey, look, I'm not interested in your solution, but I want to talk about this concept. We will absolutely have somebody reach out, put you in touch with somebody, just so we can talk through some of these concepts at a high level. And yeah, I want to thank everybody for coming out today. If you have questions, please throw them over into the questions area. I want to make sure that we get all questions heard and understood. And so I'm going to give this poll just a little bit more time to see if anybody, and if you don't click on one, you're going to get generic emails from us. So please click on not at the moment if you don't want anything from us at all, or if you want to reach out. So, all right, so we'll leave that up and we'll shift into questions. And so, you know, Fred, some of the things that I heard you talk about around, you know, the differences between doing this with open source technologies and doing this with proprietary solutions. Like, is there anything that you found that the open source technologies are not good at? Like, when would you want to consider a commercial solution? Is it for support reasons? What are your thoughts on that?
Yeah, that's a great question. I mean, I think obviously support is a big piece of it, right? Who do I go to when something doesn't work the way I expect it to? I also think that a lot of times, and this is just part of the business, right? I think a lot of the open source tools, they'll offer kind of a degraded, I guess for lack of a better term, like a degraded experience in the open source versus the commercial solution. So, you know, in certain circumstances, in order to get the functionality you want or the ease of use that you might be looking for, you end up going with a commercial solution. But I think support is probably one of the biggest pieces. I think the other nice thing about, you know, staying, at least having a foot in the open source space is giving you that kind of vendor neutral playground, right? And I think that was one of the earlier poll questions. You know, as much as, you know, we want to make sure our tools work really well with those open source tools, but we want to make sure we support those open source tools because we understand not everybody out there is rolling 100% Arista network, as much as we'd love that. You're going to be rolling with other vendors in there too, and we just want to make sure your experience with Arista is the best that it can be.
Yeah, I would agree with that. I mean, I think ultimately, you know, we see support as the #1 reason to buy a commercial solution, right? I just don't think I can get this done myself. PNAP, Arista, none of us use exclusively open source solutions, right? No matter how much we love these technologies, because we all have our core competencies, we all have the things we're good at, and ultimately, you know, we want to make sure that we stick to those things and not doing others. So, Carl, with the AVD stuff, why would a customer look at using the CloudVision collection versus the EOS collection from a Arista specific perspective?
Yeah, so that's another great question, and it's really about so out of we track and we work very closely with customers that are using Arista AVD, and out of those customers, over 90% of them choose to use CloudVision with it. So for one, that's and it's not me or it's not us that forces, is them typically coming to us is I want to use this, and I think it's and Fred did not demo this today, but the change control aspect that CloudVision does, and also the pre-validation. So it does, two things when it comes from a configuration perspective. One, when you go to roll out your change, you see a diff against the live device, right? Of course, I can do this in a playbook, but this is a much nicer graphical interface for operation people to kind of look at the change and see what's happening on my network. And then when I push the change, I graphically can orchestrate how I want that change to be deployed with various actions, and if I want to do everything in serial or parallel or have multiple stages. So again, more of a graphical interface to do that, I think, is really key when it comes to deploying to the network. And then if something fails, I have that rollback button at the top of my change control that I can roll back my configuration. The other thing that it does is, let's say I enter my configuration in Git, everything checks out, it generates the config. CloudVision will actually check. Let's say I configured an interface that does not exist on my actual switch. It will tell me before I even try to push, saying, hey, you're trying to push code or a configuration that doesn't work with the switch. And this could be anything. Actually, we were doing a POC yesterday, and we had configured for some switches a higher MTU than the one we were replacing with. It was a different model that did not support that config, and it threw at us, hey, you're trying to use an MTU value that's not supported on this device. And that tells you before you're even, before you're allowed to execute the change control. So a lot of benefits there. And then, it's more also after we deploy, all the telemetry aspect, visualizing right after my change, saying, okay, I've deployed this new network, seeing in my telemetry dashboard, I can see the routes instantly via telemetry. And observability, outside of configuration management, is another big piece of automation, right? Seeing real time what I'm doing, and the telemetry aspect that CVP provides, I think, is second to none in the industry in terms of the dashboard and the information that we're able to get.
Yeah, and I think that for us as an Arista customer, I think the other thing is you guys have made CloudVision like easy to consume from a cost perspective, right? If you're already buying a switch, it's not some huge, extra cost that just was gonna, make it overrun your budgets even at scale, right? And so yeah. I think there's a lot of value there for people that choose Arista, right? I think it's not a secret that we're a fan. We're here together doing this, right, for a reason. That we've been big fans of Arista for a long time. So
absolutely, and some people can see this also. I see people coming into automation and new to automation. Pushing directly to a switch, a configuration can be scary. This is kind of another safety net, right? Another safety net in my change control. I'm pushing to CloudVision, it stops there, and then you have full support from Arista. Whether those configlets are generated by Ansible or you've generated natively from CloudVision, that's fully supported by TAC. So the support from pushing your configs to the switches is 100% supported by Arista TAC.
Love that. All right, the time has come, friends. We're gonna give away the $100 Amazon gift card, and my friend Milena, she's already told me who it's gonna be, so I'm gonna read out the name. Mark Muonio from Dytex, Senior Network Engineer. You are the winner of the $100 Amazon gift card. And with that, everyone, we're gonna close up. I wanna thank everyone for coming today. I know that it's hard to take time out of your day. I know that it's hard to sit for 50 minutes, listen to a presentation, but I hope the content was fantastic for you as it was for me. If you need to reach us, there's every place you can reach us right there. If you indicated that you wanted to be contacted, somebody from Arista or somebody from PNAP will reach out after this call, probably the next day or two. With that, I'll leave everyone for the day. Thank you so much for joining. Thank you guys from Arista, and have a great day.
Thanks, everybody.
And yeah, thank you, and thanks for hosting us.
Absolutely.